Hi guys, this is Arccot, founder of Eschler STEM Academy. Today in my class we covered the topic inverse trigonometric functions, and it was so much fun with my students. And today I want to share with you 5 of the problems we solved today. First problem: what is the range of the function cosine arcsine 2x where x ranges from 1/2 to square root 2 over 4. Okay, before we start this problem, we need to remember how the inverse sine function behaves, right? So it is an increasing function of its argument. So in order to give you a quick overview, so this is our sine function, right? So this is how the sine function looks like. So in order to be able to find its inverse, so this is my sine function, what we do is we limit the domain of this function so that it becomes 1 to n and on to, so it's invertible, right? So we just take this piece of the sine function. So it goes from minus pi over 2 to pi over 2. And this is minus 1, and this is 1. So if you want to think in terms of the unit circle or the quadrants, okay, we are actually taking the fourth and the first, right? So this is first, second, third, and fourth quadrants. So in order to be able to define the inverse sine function, we are taking the angles here, the first and the fourth quadrants, right? The angles range from minus pi over 2 to pi over 2. Okay, this is good. So when you plot the inverse sine function, what you do is you look at the reflection of this function across y is equal to x line. So when you do that, this was sine function. Let me draw the other one here. So I'm going to plot arcsine x here as a function of x. So this was sine x, right? So if you plot it, what you see is a function like that. So it's always a good practice to remember the plots of the inverse sine function, inverse trigonometric functions in general, to solve these problems. So the domain of this guy is from minus 1 to 1, and this goes from minus pi over 2 to pi over 2. So one thing that we should notice here is that arcsine x is also an increasing function of its argument. This is what we see here. So obviously arcsine 2x is also an increasing function of x. Okay, so now we are clear with these. So now if x is equal to minus 1/2, what is arcsine 2x? So arcsine, so when we put minus 1/2, it becomes minus 1. So this is equal to minus pi over 2. So what is arcsine square root 2 over 4? This is the upper bound, so it becomes square root 2 over 2. But this is nothing but the angle pi over 4, right? So if I call this angle theta, the whole thing as theta, so theta ranges from minus pi over 2 to pi over 4. So this is clear. So now we look at the cosine function. So we need to plot the cosine function. So the cosine function looks like that, right? Let's say cosine x or cosine theta to theta versus theta. So minus pi over 2 is over here. And pi over 4 is somewhere here, right? So if you look at this region here, okay, the cosine theta then takes values between 0 and this is 1, right? So we can simply say the range is zero to 1. And this is the answer. So let's move on to the next problem. So here is our second question I want to solve today. So for x less than 0, what is arcsine x plus arccosine x equal to? Okay, so this is a multiple choice problem, so we have 4 options. So if you have something like that, it is always a good idea and a good practice to just simply put some value for x here, a special value, and if you get something which is here, one of these 4 options, you simply circle it, okay? But before this, I will remind you a few things. So let's suppose this is my alpha, this is my beta, okay? So arcsine function has a range in between minus pi over 2 and pi over 2, right? In general, then alpha is going to be in between minus pi over 2, pi over 2. However, we have a condition here. We say x is less than 0. So then alpha must be in between 0 and minus pi over 2, right? So minus pi over 2 can be included, but 0 not, because x is not equal to 0. So for alpha, we can say we are in the fourth quadrant. For beta, so our cosine function is defined or has a range in between 0 and pi in general. But it takes negative values, right, as an argument here, when beta is less than pi and larger than pi over 2. So here I can include pi, but not pi over 2, because cosine pi over 2 is equal to 0, but x is equal to 0 is not included. So when I consider these two inequalities, when I add them up, see that alpha plus beta must be in between pi and 0. This is the first observation I have. Okay, so this is the fourth quadrant and this is the second quadrant, right? So what is arcsine minus 1? So what is arcsine minus 1? Because I pick x is equal to minus 1 here. So arcsine minus 1 is simply equal to minus pi over 2 plus what is arccosine minus 1? So arccosine minus 1 is equal to pi. So this simply gives me pi over 2, which is in between 0 and pi, right? So pi over 2 is the correct answer. Okay, it was fast. It could have been even faster, but I gave you some kind of reminders. But I want to solve this problem for any x value less than 0, right? So if it's not a multiple choice problem, if it wasn't a multiple choice problem, how would we solve it, right? So no choices are given. So we can still make these claims here. So alpha is going to be in between minus pi over 2 and 0. Beta is going to be in between pi over 2 and pi. Alpha plus beta is going to be in between 0 and pi. Okay, so now we know that sine alpha is going to be x and cosine beta is going to be x. So at this point I want to remind you a really nice identity. So sine square a, so a is a real angle. Cosine square a is equal to 1. It's one of the identities in trigonometry we use a lot, right? So using this, I want to find cosine alpha and sine beta. So cosine alpha is going to be equal to. So if I use this identity, cosine alpha is going to be equal to 1 minus sine square of this angle here. So it's going to be plus minus then. Cosine alpha is going to be plus minus square root of 1 minus x squared. But wait. Alpha is in the fourth quadrant, right? So cosine alpha is going to be positive there. So you can simply take the positive root. So how about sine beta? So similarly, sine beta is going to be 1 minus x squared, plus minus. However, now we are in the second quadrant where sine function is positive. So we simply take the positive root. So I want to calculate something extra here, which is sine alpha plus beta. So what is sine alpha plus beta? So it's going to be equal to, from the identities we have, sine alpha cosine beta plus cosine alpha sine beta. So sine alpha plus beta is simply equal to, sine alpha is x, cosine beta is x, plus cosine alpha is 1 minus x square root, then we have square root of 1 minus x square for sine beta. So this gives me x squared plus 1 minus x squared, which is equal to 1. Well, I already know that alpha plus beta is in between 0 and pi. So the only way that sine alpha plus beta is equal to 1 is when alpha plus beta is equal to pi over 2. And this is the answer. Okay. So I hope it's clear. Let's move on to the next question. Hi again, this is our third question now. So what is arctangent 1 plus arctangent 2 plus arctangent 3? So we are basically summing three angles here, right? So I can simply call the first term alpha, second term beta, and the third term theta. So one thing that we need to notice here is that alpha, beta, and theta, they are both in the first quadrant. Why? Because 1, 2, and 3 are all positive. And each of these angles must be less than pi over 2, because none of these terms are infinite, right? I mean, the arguments are not infinite. So we can simply say the first observation, so alpha plus beta plus theta, so they must be less than 3 pi over 2. So this sum must be less than 3 pi over 2. It's the first observation we make. Secondly, we'll be using the identity, okay? Tangent, let's say x plus y is equal to tangent x plus tangent y over 1 minus tangent x times tangent y. So when we use this identity, let's focus on this alpha plus beta term first. So what is tangent alpha plus beta? Let's calculate it. So tangent alpha is equal to 1. So 1 plus 2 divided by 1 minus 1 times 2, right? So this gives me minus 3. Okay, the tangent of alpha plus beta is equal to minus 3. So now I'm going to call, or let's do it this way. So I'm going to calculate that. Here, I can call alpha plus beta like gamma. I defined a new angle. So according to this relation, this is equal to tangent gamma plus tangent theta divided by 1 minus tangent gamma tangent theta. And this is equal to, so tangent gamma is over here, right? Tangent alpha plus beta is tangent gamma. So it's minus 3, then plus 3, because this is tangent theta, over 1 minus 3 times 3. And this is simply equal to 0. Okay, so tangent of this sum is actually equal to 0. So then alpha plus beta plus theta must be equal to pi. So this is the angle which is less than 3 pi over 2, whose tangent is equal to 0, right? So I can simply say that alpha plus beta plus theta is equal to pi. Then this is actually the result, right? Arctangent 1 plus arctangent 2 plus arctangent 3 actually gives us this special number pi. Okay, we will move on to the next problem. Question number 4. If arcsine x is equal to arccotangent x, what is cosine of arcsine x? It's a really interesting problem, right? So we have cotangent functions, sine functions, cosine of arcsine x, so forth and so forth. But first, we need to go slow. So let's suppose this is an angle alpha and this is an angle beta. From the definition of arcsine function, okay, you need to make a claim for alpha, right? So alpha must be in between minus pi over 2 and pi over 2. So this is how the range of arcsine function is defined, right? So let's look at the arccotangent function. So beta must be in between 0 and pi. And this is how the arccotangent function is defined, right? So now, if I'm looking at this, and I'm looking at this relation, alpha is equal to beta, the only possibility here is, okay, alpha is equal to beta, but they must be less than pi over 2 and 0. So the only intersecting region here is the first quadrant, right? So alpha is then less than pi over 2 and larger than 0, and same thing for beta. So we will be working in the first quadrant. This is good. So x here must be positive. X must be positive. So this is the first observation we have. Okay, so then the next step is to draw a right triangle and see what this alpha and beta refers to. So let's call it alpha. This is 90 degrees. So sine alpha, so this is x over 1, right? And let's call this y. Okay. So what is cotangent beta? It's also equal to x, right? And this is equal to beta. Alpha is equal to beta. So cotangent beta is simply equal to y over x. And we also know that cotangent beta is equal to x, right? So this has to be is equal to x. So y over x must be equal to x. So this gives me y is equal to x squared. So here this is equal to x squared. Good. So now what do they ask? Cosine arcsine x. Arcsine is just this angle alpha. So cosine alpha is what we are looking for. So cosine alpha is going to be equal to x squared over 1. Basically x squared, right? So we'll be looking for the value of x squared. So the next step is just to use the Pythagorean theorem, right? So square of y squared plus square of x squared is equal to 1. The hypotenuse, right? So y is equal to x squared, so this is x to the 4th plus x squared minus 1 is equal to 0. Okay? So at this point set, let's define a new variable, u is equal to x squared. By the way, I can just call it y, because I'm looking for y actually. Y is equal to x squared, right? So then this gives me y squared plus y minus 1 is equal to 0. So this is now a quadratic equation. And we are looking for the positive root, right? Because y cannot be negative, it's the square root of x. So this gives me minus 1 plus square root of b squared minus 4ac. So 1 minus 4 minus 1 times 1 divided by 2. So y is simply equal to minus 1 plus square root of 5 over 2. And this is our answer. So this is equal to cosine alpha. And this is the final answer. So let's move on to the last problem for today. And this is our last question for today. Says, which of the following is not a real angle? Okay, these are all inverse trigonometric functions, and they all return us some angles, right? And we are asking which one is not a real angle. Okay. So first of all, we have arcsecant 0.2, arcsine minus 0.5, arctangent 10, arccosecant minus 5. Okay. So let's define each of these, give some names for each of these angles, alpha, beta, theta, and say gamma. Okay. So now what we know is secant alpha is equal to 0.2. You know that sine beta is equal to minus 0.5, and arctangent, so tangent theta is equal to 10, and cosecant gamma is equal to minus 5. So let's look at this one first. Sine beta is equal to minus 0.5. This is actually less than 1 and also greater than minus 1. So beta is a real angle. So this one checks out. So tangent theta is equal to 10. Well, tangent of an angle takes values from minus infinity to infinity. So this has a large range. So this also checks out. So cosecant minus 5, and we have secant of alpha, which is 0.2. So what is secant? So let's remember, this is 1 over cosine alpha, which is equal to 2 over 10. So this actually gives me cosine alpha is equal to 5. What does this one gives? This is 1 over sine gamma is equal to minus 5. So sine gamma is equal to minus 0.2. So gamma checks out as a real angle because it is less than 1 and greater than minus 1. However, cosine alpha doesn't check out because cosine alpha is 5 and it's actually greater than 1. So as we know, for real angles, cosine function is in between minus 1 and 1. Same thing for sine. So here the answer is this. This is not a real angle. So later on we will discuss how complex angles work, but it's not today's topic. So I hope you enjoyed the video. Look forward to seeing you soon. Take care. Bye.